Hello and welcome once again to practice problems for differential equations, daily practice problems. Well, almost daily. We're going to do this problem now. We're going to let y equal to 1 divided by 1 plus c1 times e to the minus x. The first thing that we have to do is part A, verify that this is a solution to the first order differential equation y prime equal to y minus y squared. Okay, so y prime equal to y minus y squared. First we have to see if that's a solution, and B, find a solution to the first order initial value problem consisting of this differential equation and the initial condition y of 0 is equal to negative 1/3. Okay, let's start with part A. So in part A, what we're going to do is we're going to recognize that we have these terms, y and y squared. So let's figure out what y and y squared would be. Well, obviously y is just, I'm just going to repeat it, but it's 1 over 1 plus c1 e to the minus x. Now y squared, that's going to be equal to 1 divided by 1 plus c1 e to the minus x, the whole thing squared. Okay, so now the question is this y a solution to this equation? So we also are going to need to take y prime. So let's take the derivative of this, y prime. I'm going to rewrite this as dy dx, and then I'm going to note that I'm taking the derivative of y, which in this case is 1 divided by 1 plus, I guess I should just say d dx of this, 1 plus c1 e to the minus x. So I just wanted to say I want to take d dx of this, and the way to do this, in my view at least, the easiest way is we're going to need the chain rule. I'm just going to draw an arrow over here, and the power rule. To see that we would want to use the power, we don't necessarily have to use the power rule. We could use another rule like the quotient rule as an example, but I'm going to prefer to change this so that it is really just 1 plus c1 e to the minus x taken to the negative 1 power. That's this whole thing rewritten this way. And now that makes it easier for us to just straightforward apply the power rule. But notice that we have something other than x inside of here. We have an x in there, but we don't, this isn't just plain x to the minus 1 power. So that means immediately that we're going to need the chain rule as well. So recalling the chain rule, we are going to need hold on here, to recall what the chain rule says, and it says that if f of x is equal to g of h of x, so two functions composed together, then f prime of x is equal to g prime of h of x, which means take the derivative of the outer function and then substitute h of x into it, times h prime, which is the derivative of that h function of x. So I'm going to need another screen for this, which we're going to go do. And what we have to figure out is what is g and what is h. So g of h of x, we want g of h of x to be equal to 1 plus c1 e to the minus x to the minus 1 power. So the outer function then, I'm going to call g of x just x to the minus 1. And then I'm going to call h of x 1 plus c1 e to the minus x. By doing this, now we can find, we're going to need g prime of x, and then we're going to have to substitute this in, because remember what the chain rule says. So we need g prime of x, which is just negative 1 times x to the minus 2. That's the nice thing about being able, this is where the power rule came in. That was very nice. So that means g prime of h of x is just equal to negative 1 times 1 plus c1 e to the minus x all to the minus 2. And then finally we have to multiply by h prime of x, which gives us h prime of x, which is just, well, the derivative, remember the derivative is a nice linear operator. You might not have heard those terms before necessarily in that way, but basically what that means is that if I have a sum of things, I can take the derivative of each term of the sum separately and then add it all together. That's a nice property of linear operators. So I can take the derivative of 1 separate from the derivative of c1 e to the minus x and then add them together. Well, the derivative of 1 is just 0, so I only have to care about this term here, and that's going to be negative c1 e to the minus x. Now technically we needed the chain rule here to compute this derivative, but hopefully it's easy enough and you've seen enough of those that you know how to do that derivative without having to resort to the chain rule again. If this was a more complicated function like minus x squared or something like that, e to the minus x squared, then maybe you would want to resort to the chain rule just to recall. But in any case, that tells us that our derivative of our original function, f prime of x, where f prime was equal to g of h of x, which is just 1 plus, oops, I don't want to write it like that, which was just this thing. This was just f. Let me rewrite this as this was just f of x. Then f prime of x must be this term times this term, and we can move this down into the denominator again. So and the minus signs are going to cancel each other, so that minus and that minus are going to cancel. We're going to get a nice c1 e to the minus x divided by 1 plus c1 e to the minus x all squared. And the question now is this the same as the function back here? So let's go back to the original one. Well, we haven't actually written y plus y minus y squared yet. So let's write that. Y minus y squared is equal to 1 over 1 plus c1 e to the minus x minus 1 over 1 plus c1 e to the minus x all squared. Well, at the moment, this does not look like the function that we have over here, f prime of x. So initially, it might look as though this is not a solution, but let's look at this a little deeper, because we don't want to we want to be sure that we actually do not have the same function. So I'm just going to rewrite f prime of x up here, and that was c1 e to the minus x divided by c1 plus c1 e to the minus x all squared. And then we said f minus, not f, we wanted y minus y squared, which was equal to 1 over 1 plus c1 e to the minus x minus 1 over 1 plus c1 e to the minus x all squared. However, we can get these into the same denominator, and then we can combine them all into a single term like this. And that's what we're going to want to do to make sure that these are not the same. And if they are the same, then it is indeed a solution. So this is the same as 1 plus c1 e to the minus x minus 1 all divided by 1 plus c1 e to the minus x all squared, because I have to multiply. Notice that this is 1 plus c1 e to the minus x squared, and this is just 1 plus c1 e to the minus x. So if I multiply, this is one of the famous tricks in mathematics, multiplying in a clever way by the number 1, or there's another famous trick which is adding in a clever way by 0. So this is one of those famous tricks. If I multiply this by 1 plus c1 e to the minus x divided by 1 plus c1 e to the minus x, then I get this denominator to be the same as this one, and then I can combine the terms, and that's all that I did here. And notice that the plus 1 here and the minus 1 here goes away, so if I finish writing this off, it's c1e to the minus x over 1 plus c1e to the minus x all squared. And hey, that looks an awful lot like this. So, and this is indeed a solution. Now let's just remind ourselves by going back what the original problem asked. So first we had to verify it's a solution, and the answer is it is, and we had to go through all this work to find that. Now we want to find the solution to this, given that the initial condition is y0 is equal to negative 1/3. So basically what that means is this means x must be 0 when we see something like that, because y is being assumed to be a function of x. You see how over here it is indeed a function of x. So let's go over here to another new board. Oh wow, I just skipped a bunch of boards here. That's not originally what my intention was, but let's go here. And basically we know that y is equal to 1 over 1 plus c1 e to the minus x, because we verified that this is indeed the solution, a solution. And now we also know that y of 0 is equal to negative 1/3. So this will allow us to get the solution. So essentially now we have to substitute this in and determine what the constant c1 is. So 0 substituted in here gives me 1 over 1 plus c1 times e to the 0, because negative 0 is still just 0, which is just really 1 over 1 plus c1. But also notice that we said this is equal to negative 1/3. So we can do this one of two ways. We can cross multiply if we want, or we can just recognize that because we have a 1 here, and we could migrate this negative down here to the negative, so to make this negative 3. So we have 1 over something equal to 1 over something, so that means that the denominators have to be the same if we have this equal sign here. So either we could cross multiply and then we would end up with a similar equation to what we're getting, or do this. So this means 1 plus c1 had better be equal to negative 3, because remember I had to migrate this negative sign down here, which means c1 must be equal to negative 4. So that means that the solution to this, with this initial value condition, with this initial value condition here that we have written, the solution would be y equal to 1 over 1 plus, I'm going to substitute in that c1, minus 4 e to the minus x, or just write it out as 1 over 1 minus 4e to the minus x. And that's my solution. That's all that I have for this video. I hope to see you again soon.